As the night settles over the quiet edges of the world, there comes a moment when the sky seems to breathe. City lights fade into a soft, distant glow, and above the darkened horizon, something ancient begins to awaken. It isn't loud. It isn't sudden. It doesn't demand your attention the way a storm or a rushing river might. Instead, it pulls you in slowly, with the gentle gravity of a memory you didn't know you had. You lift your eyes, and in that instant, the sky unfolds into a shimmering river of light stretching from one end of the world to the other. The Milky Way appears, and even if you've seen it 1,000 times, it still feels like the first. There's a strange familiarity to it, as if your mind recognizes something much older than yourself. Maybe it's because every atom in your body once drifted inside a galaxy like this. Maybe it's because our ancestors spent thousands of nights staring at this very band of stars, wondering what it all meant. Or maybe, on some deep instinctive level, the Milky Way reminds us that we're part of something vast and beautiful and impossibly mysterious. And tonight, as we take this journey together, we'll follow that river of light to its farthest shores, into the core, the halo, the dark matter that binds it together, and even into the stories it has written across human history. When you look at the Milky Way with your own eyes, you see only a faint stripe of pale light, but that whisper of brightness is the combined glow of hundreds of billions of stars, so many that if you were to count them one per second, you wouldn't finish in a lifetime. And yet the strange truth is that, in the grand architecture of the cosmos, our galaxy isn't even especially large. In the universe, it's just one spinning island among trillions. But to us, to our story, it is everything. It is home. The Milky Way is a barred spiral galaxy about 100,000 light-years across, though across is a word that hardly captures the scale. A light-year is nearly 6 trillion miles, a distance so large that our language folds under the weight of it. Even saying 100,000 light-years doesn't quite feel real. It's more like a metaphor for infinity than a measurement. And yet somehow, our galaxy keeps all of that vastness in motion with a kind of cosmic grace. Stars orbit the center like dancers caught in a gravitational current. Giant clouds of gas swirl, collapse, and ignite into new suns. Ancient star clusters drift through the halo, survivors from the earliest days of the universe. And at the very heart of the Milky Way lies a shadow, a supermassive black hole 4 million times the mass of our Sun, silent and invisible, shaping the entire galaxy without ever being seen directly. If you could rise above the galaxy and look down upon it from millions of light-years away, you'd see a luminous spiral turning slowly through space, its arms glowing with newborn stars, its core burning with the light of billions. But from inside, the view is very different. Living within the Milky Way is like living deep inside a forest. You can feel the vastness around you, but you can't see the shape of the forest itself. Every star you see in the night sky belongs to our own galaxy. Every constellation, every bright point, every familiar pattern, all of them are just local trees in this cosmic woodland. And yet the Milky Way is not only stars. In fact, most of its mass, the majority of its entire weight, is something we cannot see at all. Dark matter forms an enormous invisible halo that surrounds the galaxy, holding it together with a kind of phantom gravity. Without dark matter, the Milky Way would tear itself apart. Its stars would spin off into the dark like sparks from a wheel. But instead, they stay. They orbit. They dance. The galaxy holds. All because of a substance we still don't understand. A substance that makes up most of the universe, and yet remains completely hidden from view. What we can see, though, tells a story billions of years old. The Milky Way was born not long after the Big Bang, if not long can describe a few 100 million years, when clouds of primordial hydrogen began collapsing under their own gravity. These clouds lit the first stars, and those stars burned, exploded, and scattered the elements that would one day form planets, oceans, and life. Every carbon atom in your body was forged in a long-dead star. Every oxygen atom in your blood was born in a stellar furnace. Every iron atom in your hemoglobin was created in the heart of a supernova. We are literally pieces of the galaxy, shaped by its history. And yet, for most of human existence, we didn't know any of this. To early civilizations, the Milky Way wasn't a galaxy, it was a story. The Greeks believed it was milk spilled across the sky by the goddess Hera. Polynesian navigators used it as a celestial path, a guiding river across the Pacific. In parts of Africa, it was seen as the spine of the night sky, the framework that held the stars in place. Indigenous peoples of the Americas wove it into legends of creation, rebirth, and the passage of souls. Before telescopes, before science, before physics even had a name, the Milky Way was a canvas for meaning. And perhaps it still is. If you were to drift through the galaxy on a ship moving faster than light, an impossible dream, but a useful one for imagination, you'd pass through regions that feel like different worlds entirely. You'd glide through quiet stretches where stars are spread thin, where the darkness feels almost pure. Then you'd enter bustling neighborhoods packed with hot young stars blazing blue and white. You'd skirt around massive clouds of gas glowing with the soft red light of hydrogen emission. You'd cross through star-forming regions where stellar nurseries crackle with energy, where entire clusters are being born in bursts of cosmic creation. And then there is the galactic core, a place so dense with stars that night there would never be dark. You could read a book by starlight alone. The sky would be a fireworks display of brightness, a swirling, shimmering ocean of suns. And deep within that brilliance lies Sagittarius A, the black hole at the center. Its gravity is so powerful that stars whip around it at breakneck speeds, completing full orbits in just a few years. Imagine that. A star the size of our sun racing around an invisible point, moving faster than any human-made object ever created. And yet, from Earth, all of this is hidden behind clouds of dust that block visible light. Only radio waves, X-rays, and infrared observations can reveal the truth. The Milky Way is also on the move, drifting through the cosmic web at hundreds of thousands of miles per hour. We don't feel it, of course. Motion in space is a quiet thing, but the galaxy is not alone. It belongs to a small cluster of galaxies called the Local Group, which itself is part of a larger structure known as the Virgo supercluster. And all of that is just one branch of an even more massive formation called Laniakea, a name from the Hawaiian language meaning immense heaven. That name feels fitting, because when you pull back far enough, the universe begins to look like a tapestry of galaxies woven together into grand cosmic rivers and filaments. And the Milky Way is just one shining thread woven into that vast design. Yet despite all of this motion and structure, despite the mind-bending distances and incomprehensible numbers, there's a quiet intimacy to the Milky Way. It is, after all, the night sky we grew up with. It's the backdrop to our childhood memories, the setting for ancient myths, and the source of countless questions we still struggle to answer. And maybe that's why, whenever we look up at that river of light, we feel a strange mixture of awe and belonging. We're looking at our home from the outside, a view both humbling and comforting at once. The stars that make up the Milky Way are not evenly distributed. Some regions are bustling cities of light, others are quiet rural stretches. Our sun lives in a relatively calm neighborhood called the Orion Arm, a minor spiral arm tucked between two larger ones. This location is actually perfect for life as we know it. Too close to the core, and radiation becomes overwhelming. Too far out, and the heavy elements needed to form planets become scarce. We exist in a kind of cosmic Goldilocks zone within the galaxy itself. Not too hot, not too cold, just right. If the galaxy had a soundtrack, it would be a symphony of forces. Stars exploding, clouds collapsing, magnetic fields twisting, black holes consuming, dark matter bending space, all happening silently in a vacuum too empty to carry sound. And yet the galaxy creates rhythms, patterns, cycles. Stars live, die, and pass their elements forward like a cosmic inheritance. Nebulas bloom and fade. Spiral arms slowly turn, taking hundreds of millions of years to make a single rotation. The Milky Way is alive with motion, even though we can't see it happening in real time. Our understanding of the galaxy has sharpened dramatically over the last century. In 1920, Many astronomers believe the Milky Way comprised the entire universe. The idea of other galaxies was controversial, almost unthinkable. It took the work of Edwin Hubble, observing Cepheid variable stars in the Andromeda Nebula, to prove that it was far outside our own galaxy and incredibly distant. That realization shattered our sense of scale. The universe suddenly became unimaginably larger, and yet the Milky Way remained central to our story, the place where our sun, our planets, and our history reside. Even though we now understand the Milky Way as just one among trillions, it still holds a certain emotional power that numbers alone can't capture. When you stand beneath a dark sky far from the noise of civilization, the luminous band of our galaxy doesn't feel like a statistic. It feels like an invitation, an old one, a cosmic message woven from starlight, whispering that the universe is deeper, older, and more alive than anything we've ever known. And that somehow, in ways we don't fully understand, we belong to it. The Milky Way itself is shaped by history far older than the Sun. Over billions of years, it has grown by absorbing smaller galaxies, pulling them in with its gravity and merging their stars, dust, and dark matter into its structure. Even today, tiny satellite galaxies like the Sagittarius dwarf galaxy are being stretched and consumed, their stars forming long tidal streams that wrap around the Milky Way like faint cosmic ribbons. These stellar streams are like scars and memories, traces of ancient collisions written across the galaxy's halo. They tell the story of a galaxy that has endured countless encounters, growing stronger and more massive with each one. This process hasn't ended. In fact, the next major chapter is already on the horizon. The Milky Way is on a collision course with the Andromeda Galaxy, a majestic spiral more than twice its size. The two galaxies are being drawn together by gravity at about 250,000 miles per hour. It sounds fast, but the scale is so large that the collision won't begin for another 4 billion years. When it happens, it won't be an explosion or a violent crash in the way we might imagine. Space is mostly empty, and individual stars are unlikely to collide. Instead, the two galaxies will pass through each other like ghosts, their shapes distorted by gravity, their stars flung into new orbits, their cores spiraling around one another in a slow cosmic dance. Over hundreds of millions of years, the Milky Way and Andromeda will merge into a single enormous elliptical galaxy, a future astronomers have already named Milkdromeda. But that distant collision is only one chapter in the galaxy's life story. Right now, even as you listen to this, the Milky Way is alive with creation and destruction. New stars are forming in dense molecular clouds where gravity pulls hydrogen together until fusion ignites. Old stars swell into red giants, shedding their outer layers like cosmic blossoms. Massive ones die in supernova explosions, scattering their ashes into space where they'll one day become new planets and life. The galaxy is a recycling engine turning gas into stars, stars into elements, and elements into worlds. One of the most fascinating regions of star formation lies toward the constellation Sagittarius, the home of the Great Sagittarius B2 molecular cloud. This cloud is so massive and dense that it contains enough material to form millions of stars. And inside it, astronomers have detected complex organic molecules, including amino acids and alcohols. Yes, in a strange and poetic twist, the galaxy brews its own cosmic chemistry, crafting the ingredients for life in cold, dark clouds that float between the stars. It's a humbling thought. The seeds of biology may not be unique to Earth at all, but instead, a natural byproduct of galaxies like ours. And if we step back even farther, we find that the Milky Way itself is woven into something much larger. The universe is filled with structures so immense that galaxies become tiny pixels in a grand cosmic portrait. Our galaxy sits along a filament of the cosmic web, a vast network of dark matter and gas stretching across billions of light years. These filaments connect galaxy clusters like cities linked by highways, forming a structure that resembles a neural network on a scale we can barely imagine. The Milky Way is one node in that network, a glowing knot of stars embedded in an architecture shaped by gravity's invisible hand. Yet even within such grandeur, the experience of living inside the Milky Way remains personal. Imagine for a moment that you could rise above the Earth, drifting past the Moon, past Mars and Jupiter, past the outer planets and into the Kuiper belt where icy bodies glide through the frozen dark. Beyond that lies the Oort cloud, a spherical shell of comets that marks the outer boundary of the sun's influence. And beyond that, you begin to leave the solar bubble entirely, drifting into the interstellar medium, the thin, quiet space between stars. It's a region far emptier than any vacuum on Earth, but not completely empty. Here and there float atoms, dust grains, charged particles, and the faint remnants of ancient stellar explosions. From this vantage point, the sun becomes just another star, a single spark in a sea of billions. If you kept drifting outward, thousands of light years from the solar system, you begin to see the spiral structure of the Milky Way more clearly. The Orion arm where we live would stretch below you like a grand celestial avenue dotted with stars. The Perseus and Scutum Centaurus arms would sweep outward in beautiful arcs, filled with star clusters and glowing nebulae. And at the center, the bright core would burn like a distant fire, a crowded, luminous heart beating at the center of everything. The core itself is one of the most mysterious and extreme places in the galaxy. Packed with stars, dust clouds, and intense radiation, it's a region where physics stretches toward its limits. Within lies the supermassive black hole Sagittarius A*, a gravitational titan that shapes the orbits of everything around it. Even though black holes themselves emit no light, the matter swirling around Sagittarius A glows in high-energy X-rays as it falls inward. Occasionally, the black hole flares brightly, releasing bursts of energy that travel across the galaxy. These brief outbursts are like cosmic lightning strikes, unpredictable, powerful, and faint echoes of the immense forces at play. One of the most astonishing discoveries in recent years is that the Milky Way once experienced enormous eruptions flowing outward from the galactic center. These eruptions created massive gamma-ray bubbles extending tens of thousands of light years above and below the plane of the galaxy. They're known as the Fermi bubbles, and they're so large that if we could see them with our eyes, they would stretch across the sky like vast, glowing wings. Their origin is still debated, but they may be the remnants of ancient activity from Sagittarius A, a reminder that even the heart of our galaxy has moments of explosive, unpredictable power. Yet for all its extremes, the galaxy also contains fragile beauty. The Andromeda Galaxy, our nearest large neighbor, is visible from Earth on a dark night as a faint smudge of light. But in reality, it contains 1 trillion stars, great sweeping arms, and a brilliant core. The two galaxies, Andromeda and the Milky Way, are bound together by gravity, slowly approaching each other like two drifting islands on a cosmic sea. Their future collision is inevitable, but it will also be transformative, forging a new galaxy from their combined mass. Long after the Earth is gone and the sun has burned out, the Milky Way will continue its journey through the universe, changing shape, merging, evolving. A reminder that nothing in the cosmos is ever truly still. Even stars themselves are not permanent. Our own sun is halfway through its life, and in 5 billion years, it will expand into a red giant large enough to engulf Mercury and Venus, maybe even Earth. After that, it will shed its outer layers, forming a glowing planetary nebula, a delicate shell of gas illuminated by the remaining core. That core will cool and shrink into a white dwarf, a dense stellar ember about the size of Earth. Over trillions of years, it will slowly fade into darkness, becoming a cold, black dwarf, the final stage of a once shining star. This fate awaits nearly every star in the Milky Way. But the galaxy is not a place of endings alone. It is also a place of beginnings. Even as old stars die, new ones ignite. Even as galaxies collide and reshape themselves, new structures emerge. Even as the universe expands, the Milky Way continues to spin, creating new worlds from its raw materials. Somewhere in its vastness, planets are forming right now, worlds that may one day host oceans, atmospheres, life. Perhaps in the quiet outskirts of a distant spiral arm, a civilization is looking up at its own night sky, wondering about the universe the same way we do. Perhaps they see the Milky Way as a bright, mysterious band across their sky, never knowing that they are staring at our home. And it is here, at this point in our journey, where the cosmic scale begins to meet human scale. Because every time we look up at the Milky Way, we are participating in a tradition older than civilization. We are connecting with people who lived thousands of years before us, people who built temples aligned with the stars, who told stories about them, who navigated oceans by them, who believed the galaxy held the secrets of gods and creation. Maybe, in some sense, they weren't wrong. The galaxy did create us, not with intention or purpose, but through the fundamental laws of nature that allow stars to forge atoms, planets to form, and life to arise from the dust of the dead. And though we now understand the physics, that sense of wonder remains. The Milky Way is not just a structure of stars and gas. It's a reminder of our origins and our place in a universe larger and more extraordinary than we can ever fully comprehend. As we move deeper into the galaxy's story, we begin to see that the Milky Way is not just a collection of stars. It's a dynamic, evolving organism shaped by forces both visible and unseen. One of the most mysterious of these forces is dark matter, an invisible substance that doesn't emit light, doesn't absorb it, and doesn't interact with normal matter in any familiar way. Yet it outweighs all the stars, planets, gas, and dust in the galaxy combined. Without dark matter, the Milky Way would fly apart, its stars spinning off into intergalactic space. Instead, dark matter forms a vast halo encompassing the galaxy like a transparent cocoon, providing the gravity that binds everything together. Though we can't see dark matter, we feel its influence in the way stars orbit the galactic center. Their speeds remain oddly constant even far from the core, where visible matter becomes scarce. Something massive and invisible must be holding them in place. Dark matter is that unseen skeleton, shaping the galaxy on every level. Every star, every nebula, every planetary system exists where it does because dark matter made it possible. And yet, we don't know what it is. It remains one of the greatest cosmic mysteries, the silent architect of the universe. But there's another element of the galaxy that is just as mysterious and even more elusive: dark energy, a force that pushes the universe apart at an ever-accelerating rate. It's not restricted to the Milky Way, it permeates all of space. And while dark matter binds the galaxy together, dark energy pushes galaxies away from one another, stretching the fabric of the cosmos. One day, far in the future, galaxies may drift apart so much that their light will never reach one another. Civilizations then may see only a dark, empty sky and never know the universe was once full of galaxies. We are lucky to exist at a time when the cosmos is still visible. But not all mysteries are invisible. Some are painted in bright, glowing colors across the Milky Way. The Orion Nebula, only about 1,300 light-years away, is a stellar nursery, a place where stars are being born from swirling gas and dust. Inside this nebula, young stars heat the surrounding material, causing it to glow in shades of violet, blue, and red. Entire clusters of newborn stars emerge from this region, many still wrapped in disks of dust that may soon become planetary systems of their own. Looking at the Orion Nebula is like seeing a cosmic maternity ward, the universe in the act of creation. Farther out, in the Carina Nebula, we encounter some of the most massive stars ever discovered. These giants burn so intensely that they sculpt the gas clouds around them into towering pillars and hollowed-out caverns. Some stars in this region are hundreds of times more massive than the Sun and shine millions of times brighter. Their lives are short but spectacular. They race through their fuel and end in titanic explosions that scatter heavy elements into space. These supernovae are among the brightest events in the universe, visible across vast distances. They are the galaxy's way of recycling matter, seeding future generations of stars with the elements needed for life. But for all the brilliance and beauty of the Milky Way stars, the spaces between them are just as important. Interstellar space is filled with gas and dust so thin that it would be considered a high-quality vacuum on Earth, and yet it plays a crucial role in the galaxy's life cycle. Over millions of years, this material drifts, gathers, collapses under gravity, and forms new stars. The galaxy breathes in slow cycles. Clouds condense, stars ignite, stars die, and their remnants enrich the gas once more. It's a cosmic heartbeat measured not in seconds, but in eons. If you could drift through these regions, you would encounter wonders impossible to see from Earth. Bow shocks around runaway stars, ghostly planetary nebulae shaped like rings, butterflies, and hourglasses, rogue planets wandering alone without suns, magnetic fields twisting through clouds like invisible rivers. The galaxy is full of strange, beautiful structures sculpted by forces we're only beginning to understand. And yet, for all its grandeur, the Milky Way is just one galaxy among many. The Virgo supercluster, home to the Milky Way and tens of thousands of other galaxies, stretches across 110 million light-years. Beyond that lies the Laniakea supercluster, a titanic structure containing hundreds of thousands of galaxies, all flowing toward a mysterious gravitational anomaly called the Great Attractor. We don't know exactly what it is. Perhaps a dense region of galaxies hidden behind the Milky Way's dust, or something even more exotic, but its pull influences the motion of entire galactic clouds. Even larger still are the cosmic voids, immense, nearly empty regions of space spanning hundreds of millions of light-years. These voids, filaments, and galaxy clusters form the cosmic web, the true structure of the universe. From a great enough distance, the Milky Way becomes part of a glowing thread stretching through unimaginable darkness. And now, having traveled from the solar system to the farthest reaches of the cosmic web, we circle back to a simple truth. The Milky Way is our home. Every person who has ever lived, every life that has ever unfolded, every story ever told, all happened within this single galaxy. And yet, this home is only one tiny island in an incomprehensibly vast sea. Still, that doesn't make us small. It makes us rare. It makes us precious. It makes us part of a universe filled with possibilities we've only just begun to imagine. As we continue drifting through the Milky Way, one of the most surprising realizations is just how dynamic and alive the galaxy truly is. We tend to imagine space as frozen, unmoving, almost still, but the Milky Way is anything but motionless. Every star is on a journey, every cloud of gas is shifting, every gravitational interaction is reshaping the structure around it. We live inside an enormous cosmic traffic flow, though we are far too small and too slow-lived to truly perceive it. Our sun, for example, is not stationary at all. It orbits the center of the Milky Way at roughly 500,000 miles per hour, completing a full lap every 225 to 250 million years, a period scientists like to call a cosmic year. Since the sun was born, it has made about 20 trips around the galaxy. The last time it was in this part of its orbit, Earth didn't even exist. The land that would eventually form our planet wasn't even dust yet. That alone is humbling. As the sun travels, it drags the entire solar system with it. Planets, moons, comets, asteroids, all spiraling around the galactic center together, like passengers on a vast cosmic carousel. But the sun's orbit is not a perfect circle. It moves up and down through the galactic disk, weaving through regions with different densities of stars and dust. The conditions it encounters during this journey may even influence life on Earth. Some scientists speculate that passing through dense regions of the galaxy could expose our planet to higher levels of cosmic radiation or disturb the Oort cloud, sending comets inward. The galaxy, in its immense scale, may gently shape the story of Earth over millions of years. As we drift farther through this narrative, we come across one of the most astonishing features of the Milky Way, The galactic bar, a dense, elongated structure of stars that stretches across the central bulge. It acts like a gravitational engine funneling gas toward the center and helping shape the spiral arms. For a long time, astronomers didn't even know the bar existed because dust clouds obscure our view. Infrared telescopes, especially missions like Spitzer, finally revealed its true structure. The galaxy is not simply a spiral, it is a barred spiral, a more complex and elegant form. And it's this bar that helps feed the supermassive black hole at the center, Sagittarius A. This enormous object sits like a heart at the core of the Milky Way, though its heartbeat is felt through gravity rather than sound. And despite its mass, 4 million times the mass of the Sun, it is actually quite calm compared to the central black holes in many other galaxies. Some of those cosmic giants erupt with jets of radiation and matter that stretch for thousands of light years. Ours is relatively quiet, peacefully drawing in the occasional cloud of gas or unlucky star that drifts too close. Still, Sagittarius A is far from dormant. In 2013, astronomers noticed bright flares emanating from its region, suggesting it had consumed something, perhaps an asteroid-sized object or a clump of gas spiraling inward. And evidence in the surrounding clouds shows that, millions of years ago, it may have produced enormous energy outbursts, lighting up the galaxy far more dramatically than it does today. The Milky Way, even in its quiet era, carries scars of a more turbulent past. Around the galactic center, the stars move with astonishing speed. Some orbit the black hole at thousands of miles per second. Watching them is like seeing gravity perform a ballet, elegant, precise, deeply mysterious. The orbits of these stars provide some of the most direct evidence we have for the existence of the black hole itself. They trace perfect, elliptical paths around a point where no star can be seen, a point that emits X-rays, bends light, and distorts the fabric of space. Moving outward again, past the bar and into the spiral arms, we return to the familiar, glowing regions where stars live out their lives. But this time, imagine drifting far above the galactic disk, high enough that the entire Milky Way becomes a shimmering whirlpool beneath you. From this vantage point, the spiral structure becomes awe-inspiring. The arms stretch outward like graceful ribbons, each filled with clusters of stars and intricate lanes of dust. You might imagine that the arms are like highways, carrying stars along them, but that's not quite how they work. Instead, the spiral arms are more like traffic jams, areas where stars and gas slow down, get compressed, and heat up. It's in these compressed regions that new stars ignite. Spiral arms are factories, more active, more luminous, more vibrant than their surroundings. From far above, the Milky Way looks serene, but dip back into the disk and you quickly discover that it's anything but. There are shockwaves from exploding stars, winds blowing from massive star clusters, planetary systems forming, black holes left behind by dead suns, all of it weaving together into an ecosystem so complex and so vast that even the most advanced simulations struggle to model it in full. And yet there is something profoundly beautiful in this complexity. The Milky Way is not chaotic. It is structured, rhythmic, and governed by the simple force of gravity. Over billions of years, gravity has taken clouds of gas, dust, and dark matter and molded them into a galaxy with arms, a halo, a bulge, and a center. The entire structure exists because gravity patiently sculpts matter into coherence. But even gravity doesn't work alone. Magnetic fields pervade the Milky Way, shaping the flow of gas and influencing the birth of stars. These fields are invisible to the eye but can be observed through polarized light. They twist and bend through clouds like unseen vines, guiding particles along their lines. Without these magnetic fields, star formation would be radically different. The galaxy would evolve in an unfamiliar way. One of the most unexpected discoveries in recent years is the existence of giant bubbles of gas and energy rising from the center of the galaxy, the Fermi bubbles. These enormous structures extend about 25,000 light-years above and below the disk and are filled with high-energy radiation. We're still not entirely sure what created them. They may be remnants of ancient outbursts from Sagittarius A*, or perhaps the result of intense star formation long ago. Whatever their origin, they are colossal reminders that galaxies are not static. They erupt, they flare, they breathe. And perhaps the most fascinating part of all is that the Milky Way is not alone in its journey. It is surrounded by smaller satellite galaxies, the Large and Small Magellanic Clouds, the Sagittarius Dwarf Galaxy, and many tiny, faint companions known as ultra-faint dwarfs. Some are being slowly torn apart by the Milky Way's gravity, their stars stretched into long streams that wrap around the galaxy like ribbons. Others may one day merge with the Milky Way entirely. We are witnessing these interactions in real time, watching galaxies dance around one another in slow, gravitational choreography. This dance will eventually lead to something even grander, the merger between the Milky Way and the Andromeda Galaxy, our nearest large neighbor. Though Andromeda is 2.5 million light-years away, it is moving toward us at tremendous speed. In about 4 billion years, the two galaxies will collide. But this collision won't be the catastrophic smash we might imagine. Stars are so far apart that very few will actually hit each other. Instead, the galaxies will pass through one another, their shapes warped and twisted, their stars thrown into new orbits. Over time, they will merge into a single, enormous elliptical galaxy sometimes called Milkydromeda. Our night sky then will be filled with arcs of stars, glowing clouds and tidal streams, a cosmic masterpiece painted across thousands of light years. And through all of this, the story of the Milky Way continues, a story shaped by gravity, time, and the silent interplay of forces beyond our comprehension. A story still unfolding, still changing, still filled with mysteries waiting to be uncovered. As we continue drifting through the Milky Way, there's a moment when the sheer scale of everything begins to settle in, not as a shock, but as a quiet understanding. We start to realize that this galaxy, this immense, swirling assembly of stars, gas, dark matter, and ancient history, isn't just a backdrop to our existence. It's the environment that shaped us, the cradle that formed every atom in our bodies, the cosmic address we've always belonged to without ever fully appreciating it. And the more we explore it, the more deeply connected it feels, as though every discovery ties us a little closer to the universe around us. Floating through the quiet stretches between stars, the Milky Way takes on a different character. It becomes calm, almost contemplative. Dust clouds thin, light dims, and you find yourself surrounded by vastness so profound it almost feels spiritual. Here, far from the glowing star clusters and bright nebulae, darkness reveals its own beauty. The absence of light becomes a kind of presence, a reminder that even the emptiest regions contribute to the galaxy's balance. Gravity flows through these quiet corridors, shaping orbits, stabilizing clusters, holding everything in place like an invisible cosmic glue. Yet even in these silent interstellar expanses, life is happening on a scale too small to notice with the naked eye. Flecks of dust collide and stick. Molecules form in cold clouds, combining into more complex structures. Tiny seeds of future planets drift through the darkness, waiting for the moment when gravity gathers them into something more substantial. The galaxy is always building, always renewing itself, creating new possibilities out of the remnants of ancient stars. As we travel farther, we circle back to a simple truth. Everything in the Milky Way is connected through time. The iron in our blood was forged in a dying star. The gold in a wedding ring was created in the collision of neutron stars. The carbon that forms our cells was built inside massive suns long before Earth existed. We are not observers of the galaxy. We are products of it. We carry its story within us, written in the atoms that make us whole. That awareness brings with it a sense of perspective. All the everyday worries and noise of human life shrink against the backdrop of billions of stars, each with its own history, its own future, its own struggles between fusion and gravity. The Milky Way has survived collisions, starburst episodes, gravitational disturbances, and eons of evolution. And through it all, it has maintained an elegant structure, a balance shaped by natural laws that act with patience beyond human imagination. It's easy to think of the galaxy as an object, a thing we look at from afar, but when you really immerse yourself in its story, it becomes clear that the Milky Way is more like a living system. Stars are born, age, and die. Gas clouds flow like weather. Whole star clusters migrate like animals across a cosmic landscape. Tidal streams twist and curl like rivers. And through all of this, cosmic time moves slowly, steadily, reshaping the galaxy with each passing epoch. As we begin to approach the final stretch of our journey, imagine rising once again far above the spiral disk. From this elevated vantage point, the Milky Way spreads out beneath you like a luminous whirlpool, arms curling gracefully outward, the central bulge glowing with the light of billions of stars packed so densely that they blend into a continuous shine. The longer you look, the more details emerge: star clusters like pearl beads along the arms, dark filaments of dust tracing intricate patterns, faint halos of ancient stars drifting at the edge of visibility. It feels almost unreal, too beautiful to exist so naturally, yet here it is, our home on the grandest scale. The galaxy continues rotating slowly, completing a full turn over hundreds of millions of years. If you could watch it in time-lapse, it would look alive, breathing, shifting, evolving. New stars ignite as old ones fade. Clouds collapse and disperse. Spiral arms stretch and tighten. Entire regions brighten or dim as stellar nurseries flare to life or grow quiet. The Milky Way isn't a snapshot, it's an ongoing performance, a cosmic story unfolding in slow motion. And as we hover there, watching this celestial masterpiece turn, a sense of closure begins to form, not because the galaxy's story is ending, but because our brief tour through it has reached the point where we can finally see it as a whole. We're no longer wandering through disconnected regions. We can now understand the Milky Way as an interconnected system that shaped the universe we know and the world we inhabit. The realization that we belong to something so vast, so ancient, and so beautifully structured has a way of grounding us. It puts our place in the universe into perspective. We are small, yes, tiny compared to the galaxy itself, but we are also meaningful participants in its story. Our atoms were born in its fires. Our planet formed from its dust. Our lives unfold under the light of one of its ordinary stars. The Milky Way is not just where we live, it is what we are made of. As our journey comes to a close, imagine slowly drifting away, watching the galaxy shrink into the distance. The spiral arms soften into a single glow. The bar becomes a faint stretch of light, the central bulge a warm golden core. Eventually, the entire Milky Way becomes a delicate shimmer against the black backdrop of intergalactic space, one galaxy among trillions, but forever the most personal one to us. And in that final moment, as the light of our home galaxy blends into the darkness, we carry with us a simple truth, that in the grand story of the cosmos, we are not outsiders. We are threads in the fabric of the Milky Way, connected to its past, present, and future. That connection is our story. That story is our heritage. And that heritage stretches back billions of years, across light, dust, gravity, and time, all the way to the glowing heart of the galaxy we call home.